I thought I'd make a short video to show you how to use list in formulas. So here's my initial question. It's how many moles are in MA. MA is a variable, molar NaCl. If there are blank milliliters, volume milliliters, round your answer to 3 decimal places. I use 3 decimal places in this instance because Canvas doesn't do sig figs. So I just tell them how many decimals to round it to, and then I always have them submit their work as the last question on the test. So that's what that is, right? So here are my variables. Molarity, I just defined as MA, so I said it's somewhere between 1 and 4, and I picked 3 decimal places, right? And then here's the volume. In this case, it's milliliters, so I'm going to say it's somewhere between 300 and 600 milliliters. And again, I picked 1 decimal place. Okay, so my actual calculation here is going to be molarity times volume, but that volume is in milliliters, and I'm going to go ahead and convert that first. So down here, I have it picked to 3 decimal places. I'm going to actually define a variable down here, and I'm going to say that it's a capital V for volume, and then that's going to be my variable volume divided by 1,000. So that's my volume in liters now, right? So here, recompute. So now I have my volume in liters, right? So my answer is just going to be my molarity times my volume, capital V, and I'm going to save that. So that's how many moles I have, and that would be of NaCl. But let's say that instead of doing moles, I'm going to do grams. And so I can say how many grams are in blank molar NaCl if there are blank milliliters. Round your answer, yada yada. This would again give me moles. If I wanted to get to grams, I have to define this as a variable. So I'm going to go ahead and go back here, set N for moles is equal to MA times volume, capital V. And so again, that gives me my moles. And then I can say moles times 58.44, which is the molar mass of sodium chloride. And then I can hit save. And that's great because now I've got a variable for that number, variable for that number. Now the kids are all going to get different questions. But what I like to do is, instead of telling them it's NaCl, I like to give them a bunch of different compounds. So let me show you how that works. Let me grab something here real quick to bring it in. I'm just getting a picture. Here we go. And I'm going to save that. Sorry, I'm doing some stuff off the screen here. Alright. So let me bring in this picture here. Oh, sorry, that's my other question. I'll just upload that. Sorry, I'm bringing a picture in. Okay, so here is this picture, and I could have made a table as well, but I've got 5 different compounds, right? And they're numbered 1, 2, 3, 4, 5. Here are the compounds. So what I'm going to do is I'm going to say how many grams are in blank molar of compound number, and then I'm going to say a variable if there are blank milliliters. So now what it's going to do is it's going to pick a number. I'm going to have it pick a number between 1 and 5 to figure out, instead of just saying NaCl, now I can have them do one of these 5 compounds. And I can make this list as long as I want. Right? So now we've got a new variable, num, and that number is for these 5 numbers right here. So num is only going to be between 1 and 5, and it's not going to have any decimal places because I just wanted to pick that. Right? So let me delete some stuff here. So I still got some of the same old stuff. My molarity is still between 1 and 4. Volume is still that. But now my compound actually changes. So the first thing I'm going to show you here is how to get I need the molar mass of these compounds, right? So I need to somehow get the molar mass of whatever num is. So to do that, I'm going to make a list. All right, so let me show you what this list looks like. So here's the actual list. Actually, let me bring this down for you. Here's the Word document that I'm working off of. So here's the list right here. I called it molar mass list, and then it's equals reverse, and then these 5 numbers separated by a comma, those are the molar mass of the compounds. So compound number 1 has a molar mass of 146.36, 448.12, 149.96. So you sort of get the idea, right? So let me show you. You're just going to put that in there just as it is. So all I did was I copied and pasted that list. So molar mass list, right? And you can name it whatever you want, okay? But I named mine molar mass list equals reverse. That's just telling it that we're going backwards, but we're not really. I just always use reverse. And then it's the molar mass of the 5 compounds in the order that they are listed, 1, 2, 3, 4, 5. Okay. Now, when I save this, it's going to say NaN, right? Don't worry about that. That's what it's supposed to say. If it doesn't say NaN, then that's a problem. So now what we're going to do is we're going to pick which of these 5 numbers we need. Now, that depends on this variable num in UM, right? So the way that you do that is you set up another formula. So here's molar mass equals at. The at formula is going to look in a list and then return that whatever you're looking for. So here I'm going to copy and paste this. So paste that. Now, what are some things that can change here? This could be anything. This that's just the variable that I've defined, and I'm going to call that molar mass. Again, at is the function, so you got to use that. List is the list that you're looking in. So since I named my list, list, that's where it's looking. And then this is 5 because I have my number in goes between 1 and 5. Right? It can be between 1 and 5. And then minus number, so minus the number that you're doing. And what that's going to do is, since this is a 4, that's going to return the 4th number in this list. 1, 2, 3, 4. So it should return 499.77, which is the molar mass of strontium phosphate. Okay, so and which is messed up, by the way. That's a bad formula. I figured it out later, but that's okay. So look at that. It returned 499.77, right? Again, that's a bad formula. So if I change this, now this is number 1, which is magnesium bicarbonate, which has a molar mass of 146.36, which is the first one listed in this list. So now I have the molar mass. So I can say, I can do my volume again. V equals volume divided by 1,000. I'm going to save that. I can do my moles again. Moles equal to Ma times V. And so that gets me my moles. And now I can do the number of grams by saying molar mass times N, and now I have my grams. So that's how many grams I should have. Right? So I've been using that a lot. You can use, I've got tables as big as 20 different values. I used it for molar mass. I can use it for, for this one, for instance, I can say what is the percent of oxygen in compound number 6. And I can also use that percent of oxygen. I can say I have 5 grams of compound number 3. How many grams of oxygen would be in that compound? And I can have that variable as well. So the other thing I want to show you here while I have you here is how to do scientific notation with this. And then we'll save this. I'll show you what the kids see. So to do scientific notation, we can do something like this. Random number times 10. And then I can do superscript. And then have it EXP, right? And so what that's going to do is now I can down here my random number. My random number, RAND, has to be between 1, or has to be 1, but then less than 10. So I always set this up to be between 1 and 9, and then I have, let's say, 3, variables, or pardon me, 3 decimals. And then the exponent is, of course, whatever that exponent is. So let's say that I want it to be, let's say I'm doing moles from atoms, and I want it to be somewhere between 20 and 27. I'm not going to have that be a variable. Okay, so I'm going to go ahead and update this question. Oh, so if you don't know, you got to generate down here possible answers. I always do between 50 and 100, and then my margin of error I put it like 0.1%, which is usually pretty good. Most kids can get within that with rounding errors. Okay, so let me show you what this question looks like from the student's point of view. Save that. So, oh, you know what? I didn't put any stuff over here. Sorry. Got to put a due date. Sorry. Alright, so this is what it looks like for a kid. You can see here I've got how many grams are in 1.901 molar of compound number 4. So compound number 4 is that messed up strontium phosphate. If there are 586.4 milliliters, round your answer to 3 decimals. And then here you can see where I did scientific notation. Let me go back and show you something real quick, sorry, with that scientific notation. Alright, so I thought I'd show you how to use that scientific notation. So here I have a question, how many moles are in scientific notation, atoms of nickel, right? So here's my random number, it's between 1 and 9, 3 decimal places for that. And then my exponent, you know, you don't want decimal places in there. I mean, you could put them in there if you really wanted to, but the kids will be confused. So then what we have, and let me erase this, I was just playing around with it, is first what I would do, because I'm going to end up using Avogadro's number, is I'm going to define Avogadro's number in here as a variable. So it's 6.022 times 10 to the 23rd. So I'm going to set it up just like that, and then when I hit that, you can see that's what I got. And then for my scientific notation, so I'm going to call that just number, num. So I'm going to set that up, and that's going to be random times 10 to the exponent. And there's my scientific notation, which is 3.715 times 10 to the 24th. If I change that, 3.695 times 10 to the 25th. And so I'm just going to have my my answer then is just my number divided by Avogadro. So in this case, 61.358, so on and so forth, right? Now, if that's a negative exponent, you got to do it a little bit different. So let me show you that. So if this is negative 9, this can go all the way to, let's say, negative 3. Right? So now I got negative values, which doesn't work as well. So let me show you how to do the negative exponent. Well, let's see if it works. So we got random times 10 to the exponent. Yeah, see, it's not going to show up because it's so small, but you can do that the same way. Let's say it's between negative 2 and negative 1, just so we can see it showing up here. So now you can see it showing up. Okay, and then you can use that, like you can call that something too.